People don't care how much you know until they know how much you care. A tele-reminder from Teleradyo Marcelo, ang telearalan ng bawat Malulenyo.
Teleradyo is always at your service. Kaya naman, ang feedback mo, suggestions nyo ay mahalaga sa amin to improve our programs on air and online. Para alam ni teacher yung strengths as well as the things in your mind na mas makatutulong sa mas effective na pagkatuto sa Teleradyo. Please take time to send your feedbacks via Teleradyo Mu, which you can access by scanning the QR code on the right or typing the URL provided here, bit.ly/3ORVAY9. One more, this time you follow. bit.ly/3ORVAY9. Kaya send your hashtag TBH o hashtag RT dito sa Teleradyo Mu kung saan ang feedback mo, suggestions nyo ay mahalaga sa Teleradyo. bit.ly.
Makinig, manood na sa Teleradyo. Makinig, manood na sa Teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, Teleradyo Marcelo.
Students, excited na ba kayo para sa last quarter ng school year na ito? Ako din, excited na turuan kayo. Kaya ano pang hinihintay nyo, mga batang malulenyo? Tara, mag-aral tayo dito sa Teleradyo Marcelo. Hello and good morning, Delpilarians! Welcome to the Quarter 4 Week 1 Teleradyo Marcelo episode of Mathematics 8, ang telearalan ng bawat malulenyo. This episode is made possible by the Teleradyo Marcelo team and Junior High School Mathematics Department. Kumusta kayo? Sana nasa mabuti kayong kalagayan. Mag-aral pa rin tayo kahit mahirap. I-try natin pasalamatan ang ating mga magulang sa pagsuporta sa atin para sa pag-aaral na ito. Of course, ang ating mga guro na walang sawang nakikinig at nag-e-explain kahit malayuan. Sila ang nagsusort ng mga modules ninyo. Thank you po mga teachers. And of course, ang suporta sa amin ng administrasyon mula sa Marcelo H. Del Pilar National High School headed by our ever-loving principal, Ma'am Vivo. Maraming salamat po. I am Mr. Richard M. Cruz, your Mathematics 8 teacher broadcaster. For today's episode, we will discuss Quarter 4, Week 1 lesson entitled Illustrating Theorems on Triangle Inequality. And for our learning competency, we will learn how inequalities are illustrated on a triangle or a pair of triangles. With that, we will use the different triangle congruence postulates and theorems that were discussed by Ma'am Perlaxa from the previous Teleradyo episode. So, bring out your paper, pencil, and your favorite snacks. Take your most comfortable seat and let's get started. Let's take a quick review by identifying the terms described. You may post your answers on the comment box with your full name and section. Let's have the first one. We have to arrange letters to identify the term being described. Letters B, O, A, tringleECR. That describes a line, a ray, or a segment that divides an angle into two congruent parts. What's that? Did you answer angle bisector? Correct. Let's have this next one. How to construct an angle bisector? Let's say, for example, we have here angle GBC with 30 degrees. Let's have the pointer of the compass on points D and E so that we'll have an intersection point F inside. And we can extend that ray from point B, the vertex of our angle, and we can divide 30 degrees into two congruent angles. Then our angle bisector is ray BH or ray BF. Therefore, we can have two congruent bisect angles. That is angle HBC and angle HBG, which are all equal to 15 degrees. Next, arrange the letters to identify the term being described. That is a straight edge used in constructing angle bisectors. What's that? Let's check if your answer is correct. Ruler. As simple as that, right? And that is a word describing lines forming right angles at the intersection. Take time. Please arrange the letters NILEDPAPERCUR. Let's see. Correct. That's perpendicular. And when we say perpendicular lines, they form right angles. And that right angle is exactly 90 degrees in measure. But how do we construct a perpendicular bisector? Let's say we have here segment AB. Get your pointer of the compass on point A and create an arc as well as in point B. That arc should be more than half of the segment AB. Then we can have two intersections. Those points should be joined together so that we can have a perpendicular bisector. And that intersection is at point M. Therefore, that angle near M is 90 degrees and AM is congruent to BM. Next, arrange the letters to identify the term being described. SOAPCMS. And that is a tool used to draw arcs in constructing angle or perpendicular bisectors. I think I said this word earlier. Okay, that is a compass. As simple as that. Did you get all of the answers correct? Okay, let's see. Let us solve for the unknown values. We're still reviewing the previous topics. In triangle ABC, segment BY is the angle bisector. The measure of angle ABY is equal to 5x plus 2 degrees. And the measure of angle CBY is x plus 34 degrees. The measure of angle ABY, the measure of angle CBY, and of course, the measure of the whole angle ABC. 30 seconds. This time, Since we have two congruent angles, that's ABY and CBY, we should have an equation 5x plus 2 is equal to x plus 34 to make it easier. Time's up. Let's see if you solved it properly. X is equal to 8. From the equation 5x plus 2 is equal to x plus 34. Simplifying both terms and using the properties of equalities, we can have x is equal to 8. And if x is equal to 8, therefore, we can substitute 8 to 5x plus 2 to find the measure of angle ABY, which is equal to 42. Very good. And they should have the same angle measure with angle CBY since they are congruent bisected by segment BY. That's 8 plus 34. It will give us 42. Very good. And of course, combining those two congruent angles will give us the measure of angle ABC. Correct. That is 84 degrees. So, do you remember the properties and techniques in solving for an unknown value? Yes, those are the steps. But we're not yet done. There you go. Solve for the unknown values in triangle ABC and with segment BY as the perpendicular bisector. Okay. And AY is equal to 3y and CY is equal to 2y plus 5. Now, we're dealing with congruent segments now. Okay? Again, AY should be equal to CY since that is divided by the perpendicular bisector BY. Find the value of y, solve for AY, solve for CY, and of course, solve for the longer side AC. 30 seconds. Please take note that AY is congruent to CY or segment AY is congruent to segment CY. Therefore, you can use the equation 3y is equal to 2y plus 5. Simplifying both sides of the equation will give us the value of y. And we can substitute that value to the expression 3y and 2y plus 5. Let's see. Very good. Y is equal to 5 and AY or segment AY is equal to 15 units. The same with segment CY. And adding them, 15 plus 15 will give us 30 units. Okay. Do you find it hard to answer these review questions? Or you missed almost all answers? Please do find time to contact your approachable mathematics teachers. They are more than willing to guide you and address your difficulties. Do you get almost all correct answers? Great job. As you have noticed, our lessons from the previous third quarter topics are more on investigating the properties of triangles with clues and properties supported by definitions, postulates, and theorems. However, we are challenged to think deeper and imagine things beyond congruent triangles. What you can see is a puzzle in which you have to put the numbers from 1, 2, 3, 4, 5, 6, 7, 8, 9, so that the summation of each side with the external side of the triangle is exactly 20. Draw a sketch of this figure and try putting the numbers on their proper places. Let's have 60 seconds or 1 minute. While you are answering the puzzle, Do you know that this symbol represents an elephant Hindu god named Ganesha? Yes, that's the name of the god, Ganesha. Looks like an elephant. That's half an elephant and half human. This triangle symbolizes intellect and power. What other supernatural beings that you know uses triangles or the like? Have you solved the puzzle? 10 seconds. Okay, let's check. Again, we have to arrange the numbers from 1 to 9 so that the sum of each side, guided by the yellow line, will be equal to 20. This is the correct combination. 1, 2, and 3. Yes, those are the external points of that triangle. How about 4, 5, and 6? Yes, those are the vertices of that triangle. 7, 8, and 9. Very good. Those are the midpoints of each side of the triangle. Great job, grade 8 students. We've warmed your sleeping brains and ready for the new lesson. During the discussion, your active participation is highly encouraged by writing your answers on the comment box. We discourage commenting unnecessary words or phrases that are not related to the subject. So let's proceed and make this learning fun and easy. To give you a glimpse of our learning journey, here are the questions for your guide. The first one: what relationship can be shown between the opposite sides and angles? In order to form a triangle, what should be considered among its sides? What relationship can be drawn between the exterior and remote interior angles of a triangle? And we will answer the question: which triangle inequality theorems consider two triangles? Let's begin with the first theorem. The first theorem, the first theorem is the side angle relationship. We have theorems 1 and 2, SS, AA, and AASS, respectively. What are those? Let's have this example. Take a look on the relationships of the sides and angles of the given triangle. From 90 degrees, going down to the side of the triangle, we have 7 centimeters. And from 30 degrees, we have the side 3.5 centimeters. Our triangle measures 3.5, approximately 6.1, and 7 centimeters on each respective sides, as well as the angles are equal to 90, 60, and 30 degrees. Let's check. Is that equal to 180 degrees? 90 plus 60 plus 30, that is equal to 180 degrees, in which that is a property of the angle measure of the interior angles of a triangle. It should be exactly 180 degrees. And take a look on the relationships of the sides and angles of the given triangle without their measures. From the vertex J, that is angle J, opposite side OY. And we also have from vertex O, we have that angle O, opposite side YJ. Okay. So what have you noticed, class? It states that in triangle inequality theorem number 1, the longest side is opposite the largest angle. The shortest side is opposite the smallest angle. And as well as theorem number 2, yes, that is the largest angle is opposite the longest side and the smallest angle is opposite the shortest side. Let's take a look. Let's go back to our triangle that we showed you earlier. Okay. Have you seen vertex J with angle J? Yes. If we want to identify the side opposite that angle, we should take a look on the missing letters of that triangle. Since that is triangle JOY and we have angle J, there are two missing letters to complete the letters of the triangle JOY. Therefore, the opposite side of angle J is OY. That's it. JOY to complete the name of the triangle. As easy as that. How about angle O? Yes. The missing letters to complete the name of the triangle is Y and J. That's it. You only have to find the missing letters of the triangle so that we may know what is the opposite side of that angle. The same thing as if we want to know the opposite angle of that side, we have to find one missing letter since we are using two letters for a side of a triangle. Since we have side OY, therefore the missing letter is J, and that is the name of the angle opposite to side OY. As well as if we have side YJ, therefore the missing letter is letter O. That is the opposite angle of that given side. And we should also consider that the longest side is opposite the largest angle. And conversely, the shortest side is opposite the smallest angle. On the other hand, the largest angle is opposite the longest side, and the smallest angle is opposite the shortest side. Let's answer this practice exercise to test your understanding. Feel free to answer each question. Please don't forget to indicate the number or numbers for each answer, as well as your full name and section, so that your respective math teacher will acknowledge your comment. In triangle EFG, the longest side is EF, which is the largest angle. Is it A angle G, B angle E, C angle F, or we cannot determine that angle? For number 2, in triangle EFG, the shortest side is EG, which is the smallest angle. Is it angle F, angle G, angle E, or we cannot still determine which one? The clue is you have to complete the letters of the name of the triangle so that you will know the missing angle. In triangle EFG, the side FG is neither the longest nor the shortest side, which angle is neither the largest nor the smallest. Now, we are talking about the middle or the median of those sides. Is it angle F, angle G, angle E, or we still cannot determine that one. For number 4, in triangle EFG, the smallest angle is angle F, which is the shortest side. Side EF, side FG, side EG. In triangle EFG, the largest angle is angle G, which is the longest side. Side EF, side FG, side EG. I will take a look on the comments from our Facebook. We have comments from Jan Colin Baula, number 1, letter A. The same with James Cruz, Von Eisen Cordovilla, Rain Paganiban, Erwin Fabian, Prince Gabriel Chico, Denise Francesca, Roy Carmela Cua, Hannah Graciela Segura. Great job, guys. Ariana Chariz Santiago, Linus Ian James Lobrino, Adriana Chloe S. Demision, Jan Colin Baula, Roy Carmela Cuba, Chris Wyatt Avila, Janelle Carpio, Ralph Nathan Mansilungan, Suzanne Pascual, Jan Colin Baula, Lee Samuel Tan, Erwin Fabian, Josefina Gatakelo, Carmela Talamayan, Zeldrick Rodriguez. We have answers from Ralph David, Denise Salandanan, Janelle Carpio, James Cruz, Micaela Rosaldes, Erwin Fabian, Sebastian de la Cruz, Denise Francesca. Okay. And more. Thank you so much for your participation, class. Let's see. Let's check if your answers are correct. There you go. Very good, class. Next. We are now on the third theorem, the triangle inequality theorem, that involves the sum of lengths of any two sides and comparing it to the third side. First question is, can you form a triangle using these sticks? We have a stick that measures 6 centimeters, 9 centimeters, and 15 centimeters. Why? Or why not? Okay. The triangle inequality theorem number 3 states that S sub 1 plus S sub 2 is greater than S sub 3. Or in any triangle, the sum of the lengths of any two of its sides, that's side 1 represented by S sub 1 and side 2 represented by S sub 2, should be greater than the length of third side represented by S sub 3. Okay. It's just when we have to compare the third side, the sum of the first side and the second side must be greater than that third side. Or else, if it doesn't fit, then we cannot have or we cannot form a triangle. Let's analyze this problem. Let's see who's lying. Marites tells us that that she constructed a triangle whose lengths of the sides are 2 meters, 3 meters, and 5 meters. Karen tells us that she constructed a triangle whose lengths of the sides are 3 meters, 4 meters, and 5 meters. Who's lying? How do we determine who's telling the truth? That triangle inequality theorem number 3 will help us. Let's construct a table analyzing the sides of the triangle of Marites, which are 2 meters, 3 meters, and 5 meters. And let's have those combinations so that we can add and compare them to to the third side. The first one is side 1, which is 2, and side 2, which is 3. If we add them, that is equal to 5, which is exactly the same length as the third side. They are equal. Side 1 can be 3 and side 2 can be 5. Adding them will give us 7, which is greater than 2 as the third side. If we have side 1 as 5 meters and side 2 as 2 meters, we can have 7. That is equal to 7, and that is greater than 3. Okay. Have you seen that the first combination or the first row gives us an equal sign or equal relationship? Therefore, that first row does not fit on ang on triangle inequality theorem number 3. Okay. If at least one doesn't fit the inequality, therefore, we cannot form a triangle. Marites is lying. Okay? Let's see if Karen is telling the truth. Karen has 3 meters, 4 meters, and 5 meters as the sides of the triangle. Constructing the table, we can give us 3 plus 4, that is 7, which is greater than 5 as our third side. What if we have 4 plus 5? That is 9, greater than the third side, which is 3 meters. And if we have 5 plus 3, the first side and second side will give us 8, which is greater than the third side, which is 4 meters. Therefore, all of the inequalities are greater than, and we can now conclude that Karen is telling the truth. Very good, Karen. It follows that when we have the absolute value of the difference of side 1 and side 2, that can also be less than the third side. What is the absolute value? Isn't it that we are dealing with lengths and measures? There are no, or we cannot consider negative lengths or measures. We cannot have negative 2 kilometers or negative 5 meters. That is impossible. So that we can have the absolute value. Taking the absolute value will remove the negative sign. As easy as that. In any triangle, the difference of the lengths of any two of its sides is less than the length of its third side. Okay, so if we add the two sides, it must be greater than the third side. If we take the difference of the two sides, that should be less than the third side. Okay, let's have a practice exercise. Given P, Q, and R as the sides of a triangle, which of the following is the correct inequality of their measures? Okay. Let's read your comments. Okay. We have answers from James Cruz from grade 8, section 1. His answer is letter 6, number 6, letter B. Okay, let's see. Camille Hazel Antenco, Zeldrick Rodriguez, Prince Gabriel Chico, Ariana Charis Santiago, Cyril Komatsu, Adriana Chloe de Michon, John Justin de los Reyes, Janelle Carpio, Linus Ian James Lobrino. We are with number 6, Linus, not number 1. Erwin Fabian, Chris Wyatt Avila, Haley Avila, Frances Angelo Carmen Leasing, Angel Nicole Carlos, Camille Hazel Antenco, Zeldrick Rodriguez, Denise Francesca, Janiel Michael Lopez, Earl Borlongan, Lizelle de la Cruz. Okay, those are your answers. For number 6, we have choices P plus Q is less than R. Letter B, R is less than P plus Q. Letter C, R plus Q is less than P. And R is greater than Q plus P. Number 7, given two sides of a triangle whose lengths measure 30 centimeters and 35 centimeters, find the possible length of the third side. Okay, if we add 30 and 35, that's equal to 65. Okay, what should be the inequality to be used? Okay, that should give you a clue. Is it 65? Is it 70? Is it 32? Is it 5? And choose the set of possible lengths of the sides of a triangle. We have the first one, 5, 5, and 10. Letter B, 7, 7, and 1. Letter C, 3, 9, and 15. Letter D, 5, 10, and 3. Okay, let's see the correct answers. Okay, letter number 6, that's letter B, correct. Okay, number 7 is 32. Why not 65? Because 30 plus 35 is equal to 65. Okay, why not 70? Because that is greater than 65. It should be less than 65. And letter D is also impossible because if we subtract 35 and 30, the answer is 5, which is equal to 5 centimeters as the third side. That is impossible. It should be greater than, okay, 5 centimeters. And choose the set of possible lengths of the sides of a triangle. One, letter A is impossible, 5, 5, and 10, because 5 plus 5 is 10. Letter C is also impossible. 3 plus 9 is 15, which is less than 3 plus 9 is 12, which is less than 15. It should be greater than uh, 9 plus, sorry, 3 plus 9 is 12. That is less than, okay, 15 centimeters. So it should be less than 12, not greater than 12, because 15 is greater than 12. Okay. And 5 plus 10, that is 15, which is less than the 3 centimeters is less than, but if we subtract 5 and 10, it will give us 5 centimeters. Okay, so it should be greater than 5 centimeters, not less than 5 centimeters, because 3 is less than 5 centimeters. We will accept if the third side is 6, 7, 8, or 9, but not 3 centimeters. Okay, we're not yet done. Let's have numbers 9 and 10. Given two sides of a triangle whose lengths measure 30 centimeters and 35, the following are all possible lengths of the third side except for which one? And number 10, all sets are possible lengths of the sides of a triangle except for which one? Okay, I'll give you time to answer this one. You can have a scratch paper for your solutions, or maybe you can use your calculator for easy calculations. Okay, let's see the correct answer. Okay, very good. So 75 is impossible because 30 plus 35 is 65 because it exceeds 65. 75 exceeds 65. Okay. 27 plus 57 and 17. If we take the difference of 57, 27, okay, that is 30, which is greater than 17. And 17 is less than 30. Okay. A bit tricky, right? But did you get a perfect score? Did you get all of it, the answers correct? Okay, great job. Now let's have the exterior angle inequality theorem. The exterior inequality angle theorem states that the exterior angle is equal to the sum of the two remote interior angles. What is an interior angle and what is a remote angle or remote interior angle? Therefore, we can conclude that the exterior angle is greater than the remote interior angles. Okay. Let's take a look on this animation. Have you seen the red angle? That is our exterior angle. An exterior angle is formed after extending a side of a triangle, forming that exterior angle A. Okay, in red, colored in red. And as you can see, as you have noticed, if we add the angles D and C, that is equal to the exterior angle A. Sounds like magic, right? We can explore more of that when we go through deeper discussions. The exterior angle of a triangle is again an angle formed by one side of the triangle and the extension of an adjacent side of a triangle. That is the exterior angle. Okay. Therefore, the angles inside the triangle are the interior angles of a triangle. So, again, we can have the outside, which is the exterior angle, and the inside, which is the interior angle of a triangle. And the exterior angle theorem states that if we add those interior angles, that is exactly equal to the exterior angle. Okay. For example, if we have a triangle whose interior angles or remote interior angles are 80 and 40, take note, that is a remote interior angle. 80 degrees is the remote interior angle, and 40 degrees is the remote interior angle of that triangle. If we add them, 80 plus 40, that is exactly 120. That is the measure of our exterior angle. How come? It's because we have a linear pair, and linear pair is equal to 180 degrees. Therefore, that adjacent angle close to 120 degrees is supplementary, which is equal to 180 degrees. And the exterior angle inequality theorem states that the measure of an exterior angle of a triangle is greater than the measure of either of the two remote interior angles. For this example, the exterior angle is D, that is greater than angle A, remote interior angle A, and remote interior angle B. Of course, by the property of addition, okay, if A plus B is equal to D, therefore A is less than D and B is less than D, or D is greater than A or D is greater than B. Nonetheless, one of A or B is equal to 0, but that is impossible for a triangle to have a 0 degrees. Okay, let's have a practice exercise. Which of the following statements is true? Please consider the diagram triangle ABC with an extended side that forms an exterior angle from line D, A and B. Okay, so which of the following statements is true? Letter A, the measure of angle DAC, that is the exterior angle, is greater than measure of angle B. Angle B is our remote interior angle. How about letter B? The measure of DAC, the exterior angle, is less than the measure of the remote interior angle B. Letter C, the measure of DAC is less than the measure of BAC. Okay, that angle BAC is close to the exterior angle. Or the measure of angle BAC is greater than the measure of angle DAC. And number 12, which of the following inequality is true? The measure of angle DAC is less than the measure of angle B. The measure of angle DAC is less than the measure of angle C. The measure of angle DAC is greater than the measure of angle B. or the measure of angle BAC is greater than the measure of angle DAC? Let's take the answers from the following students. Okay, James Cruz, very good. Lagi kang nauuna sa ating recitation. Thank you so much for your participation. We also have response from Jared Ignacio Centeno, Renia Joy de la Cruz, Ariana Charis Santiago, Maricel Bartolome, Vincent Maren Magsakay, Adriana Chloe Demision, Princess Altea Valdez, very good, Angel Nicole Carlos, Andrea Kit de la Cruz, Roy Carmela Cua, Erwin Fabian, Delis Salandanan, Janelle Carpio, Chris Wyatt Avila, okay, very good, Cyron Dale Campana, Anika Beatriz Marasigan, Maricel Bartolome, Vincent Maren Magsakay, Floren Daniel Santiago, Suzanne Pascual, Zeldrick Rodriguez, Rachel Ann Reyes. Okay, and more. Very good. Thank you for your participation, class. These are the correct answers. Okay. Next. Number 13. Which of the following inequality is true dealing with the same diagram? Number 13, if which of the following inequality is true? Letter A, the measure of angle DAC is the less than the measure of angle C. And the measure of angle C is greater than the measure of angle DAC. Which one is correct? Okay. The measure of angle DAC is greater than the measure of angle C. Is that correct? Letter D, the measure of angle B is greater than the measure of angle DAC. And for number 14, this is very easy. If the measure of angle DAC, our exterior angle, is equal to 100 degrees, then the measure of angle CAB is what? Okay. If the measure of angle DAC is equal to 100 degrees, then the measure of angle B plus the measure of angle C is what? As easy as that. Okay, let's see if your answers are correct. Okay. Since the exterior angle and the angle close to that are supplementary, therefore, the measure of angle CAB is equal to 80 degrees. Very good. If the measure of angle DAC is equal to 100 degrees, which is our exterior angle, therefore, the two remote interior angles, angle B and angle C, should also be equal to 100 degrees. Very good. Okay. Great job. Almost all of you got the correct answer from our response from Facebook. Thank you so much. Now, let's have the hinge theorem, or commonly known as the SAS triangle inequality theorem. Okay. This is different from the SAS congruence postulate. Okay. Because the sides are congruent, but the included angle is not congruent. By this time, the hinge theorem and the following theorem will deal with two pairs or with two triangles or one pair of triangle. Okay. From our previous theorems, we are using only one theorem, one triangle. But by this time, the hinge theorem and the following theorem will use two triangles. They are not congruent, but at least two of its sides are congruent. Now, let's take a look. Okay. Can you please notice this animation? We have a hinge and stick AH and stick BH. Okay, and the rubber band is the third side of the triangle that can be expanded. Okay, or it can be stretched since that is a rubber band. And it serves as the third side of our triangle. So let's imagine a triangle with that movable hinge on vertex H. Okay. Only the third side is moving as well as the angle formed on the hinge. Okay. So what have you noticed, class? Okay. There is a direct relationship between the hinge angle and the rubber band, which is stretched. Okay. The larger the angle, the longer it stretches. Okay. While if we have a shorter angle or a smaller angle, which is narrow opening, it means or it directly gives us a shorter side of that triangle. Okay, we have the hinge theorem or the SAS triangle inequality theorem. If two sides of a triangle are congruent to two sides of another triangle, and the included side or included angle of the first is larger than the included angle of the second, then the third side of the first angle is longer than the third side of the second triangle. Nalito kayo, no? Masyadong mahaba yung definition ng ating theorem. But here's the clue. Since angle K is larger than angle H, comparing two angles, one is larger and one is smaller. Yes, angle K is the larger angle and angle H is the smaller angle. It follows that CD, which is our stretched rubber band, is longer than AB, less stretched. Okay, this is the uh, the theorem that I am talking to you. The larger angle gives us longer side, and the smaller angle gives us shorter side. As easy as that. Then, what is the converse of hinge theorem or the SSS triangle inequality theorem? By this time, we're not talking about or we're not dealing anymore with the included angle. We are now dealing with all of its sides of a triangle, but only at least two pairs of corresponding sides are congruent. The third side is shorter or longer than the other. The converse of the hinge theorem, also known as the side-side-side triangle inequality theorem, if two sides of a triangle are congruent to two sides of another triangle, and the third side of the first is longer than the third side of the second, then the included angle in the first triangle is greater than the included angle in the second triangle. Okay, let me explain that to you. Yes, dealing with the same hinge, since side CD is longer than side AB, it follows that angle K is larger than angle H. Let's have the longer side, and it gives us a larger angle, while the shorter side gives us the smaller angle. Okay, let's have this practice. Please take a screenshot of this presentation. Okay, and these are the correct answers. There we go. I apologize for having make this quick because we do not have enough time. Take a screenshot on problems 19 and 20. Okay, you can ask your teachers about this one. Okay, those are the correct answer, and you can take a screenshot of the correct answer. So let's summarize our learning for today. What relationship can be shown between the opposite sides and angles? Okay, the opposite sides and angles are directly related to each other. The larger the angle, the longer is the opposite side, or the shorter or the smaller the angle gives a shorter side. In order to form a triangle, what should be considered among its sides? If we add two sides, that should be greater than the third side. Okay, and if we take the difference, okay, when we subtract the two sides, it should be okay less than the third side. What relationship can be drawn between the exterior and the remote interior angles of a triangle? Having that if we add two remote interior angles, that is equal to the exterior angle, or the remote interior angle is less than the exterior angle, or the exterior angle is always greater than one of the remote interior angle. And which triangle inequality theorem considers two triangles? Those are the hinge theorem and its converse. And for your assessment, please answer the pages 8 and 9, numbers 1 to 10. Please use the answer sheet provided to you. Okay. Maybe you have some topics or points that aren't clear for you. Don't worry, the Teleradio team will upload this episode on Facebook and YouTube. So don't forget to follow, subscribe, click the like and share button for this video on our Facebook page and YouTube channel. No available resources for our social media platforms. Your respective mathematics teachers got you. We have Ma'am Emma Garcia, Ma'am Perlaxa, Ma'am Charito Ferrer, Ma'am Chelsea De Luna, Sir Emer Narciso, Ma'am Lani Rio Pirio, Sir Marlon Atienza, and of course, yours truly, Sir Richard Cruz, to entertain your questions through Messenger or SMS. And that's an episode full of learning. Now you're ready to answer the assessment part of your module. Okay. Do you have questions, ideas, suggestions, or clarifications in mind? Please do not hesitate to contact your Mathematics 8 teacher. I would like to take this opportunity to thank our ever youthful Dr. Vivo, the principal of Marcelo H. Pilar National High School, and of course, the assistant principals, especially our department head, who never get tired, Sir Marco Recevio, as well as Ma'am Donna Estacio. Also to my colleagues from the Junior High School Mathematics Department who are now watching with us. Thank you. And of course, shout out to the Teleradio team. This Teleradio episode will never be possible without the technical working group. Shout out po sa inyo. Mabuhay po kayo, ma'am. With Ma'am Hilda, Ma'am Bernadette, Ma'am Isabel, Sir Paulo, and Sir Frederick. Muli po, mabuhay po kayo. Maraming salamat po. I am Sir Richard, your Mathematics 8 teacher broadcaster for this week na nagpapaalala mula sa Love Radio. Una, magdasal ka para pambuhay ka. Pangalawa, mag-face mask ka para mabuhay naman ng iba. Yo! Again, this is Sir Richard, now signing off. Salamat po.
Makinig, manood, nasa Teleradyo. Makinig, manood, nasa Teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang